Hello guys, this is Sayed Mohammad Wakas. The topic which I'm going to discuss today is related to the sprinkler system hydraulic calculation. So as you can see that there I have prepared an Excel sheet for sprinkler system hydraulic calculation. And so this is the drawing which I'm going to use for sprinkler system hydraulic calculation. And here are the tables and charts which I'm going to use during calculation. So first of all, you have to understand the drawing and then we can start the hydraulic calculation. As you can see that this is the dining room area drawing which I have in here. You can see that we have total 8 sprinklers in here. The blue dots representing the sprinklers 1, 2, 3, 4, 5, 6, 7, 8. So we are gonna perform the hydraulic calculation for this dining room area. So you can see the distance between the sprinklers is mentioned in here, and these are the branch lines, and this one is the cross main in here. So we have to calculate up till this point. So I'm gonna do hydraulics up till this point. So you can see that I have divided drawing into different sections, that is 101, 102, 3, 4, 1T and 3T. So you can see the different sections on the drawing. Just for easiness, we have divided this drawing into different sections. So let's move back to our calculation sheet. So you can see that I have write the sections in here: nozzle identification and location, and then we have a flow rate column, pipe size column, and pipe fitting summary, then equivalent length, pressure loss in psi and bar, then we required pressure, and then the formula which we used in here. So first of all, whenever you are performing the hydraulic calculation, you have to check the space. So what kind of space is this? According to that, you have to select the fire hazard occupancy. So the space in here in the drawing is dining room. So it's covered in the light hazard occupancy. So I have used the light hazard occupancy as per NAFPA 13 standard. You have to select the occupancy hazard, whether it is light hazard, it is ordinary, or extra hazard. You can see here in the chart light hazard, ordinary, or extra hazard group. So according to that you have to select. So I have select this light hazard. So first of all you have to do is you have to calculate the flow rate across each sprinkler. You can see in here. So how did I get this flow rate across each sprinkler, that is 15.5 GPM? So first of all you have to get the area covered by each sprinkler. For light hazard occupancy, the area covered by each sprinkler you have to check from NAFPA 13 standard. So I took 155 square feet as per NAFPA 13 standard per sprinkler. This is the coverage area, and this point 1 is the density. So you need to multiply area with the density to get the flow rate across each sprinkler. So how did I get this 0.1 density? Let's move back to our chart. This is the density chart. On x-axis you can see that density is in GPM per square feet. Y-axis we have area of the sprinkler operation in a square feet. So since we said that we have ordinary hazard group, so you can see that the minimum area of sprinkler operation is 1500 square feet. At this minimum area we have minimum density is 0.1 GPM per square feet for this ordinary hazard group. So that's how we have selected 0.1 GPM per square feet. So we have used 0.1 GPM per square feet multiply with 155 is the area covered by each sprinkler. So total flow rate across each sprinkler is 15.5 GPM. This is basically our small q which we have to use in here. So what is small q and what is capital Q? Small q is basically the flow rate across each sprinkler, and capital Q is basically the total flow rate. So at this point we have small q and capital Q both are equal because we are starting from this point. So one more thing, first of all you have to select the most remote hydraulically uh, sprinkler, or the sprinkler that is farthest away from the source of supply, the most remote outlet from the source of supply, so we are going to start our calculation from this point. So at this point, small q and capital Q both are equal, that we already calculated, 15.5 GPM. So we have to use here 15.5 GPM, small q and capital Q. Already applied the conversion factor, so it's converted this into liters per minute flow rate. So this Q I have used 15.5. This is the flow rate across each sprinkler. And this is nozzle identification and location from 102 to 101. You can see that from this 102 to 101 we have one sprinkler in here. So we can go in here and write the GPM, and then we have to write the pipe size. So nominal diameter of in the drawing, if you see that it's 1 inches. So we have write nominal diameter 1 inches, but we have to write the actual internal diameter over here. So for 1 inch pipe size, actual internal diameter is 1.049. So we have to write actual internal diameter, because when we are using the equation, we have to use the actual internal diameter instead of this nominal diameter. So fittings, as you can see, this is a straight pipe. There are no fittings included in this one from 102 to 101, so it's not applicable. So now we have to write the length, straight pipe length. If you want to check, you can check in here. So one thing over here, the distance between the sprinklers on the branch line, this is the branch line, distance between the sprinklers is not as per NAFPA 13 standard. So let me write this as per NAFPA 13 standard. If you remember my video on how to place the sprinklers in Revit as per NAFPA 13 standard, there I have used S and L rule to show you how you can place sprinklers as per NAFPA 13 standard. So I'm going to apply the same rule to get the distance between the sprinklers on the branch lines. So as you can see that this 35 feet 11 into 1 by 2 inches is the width of this dining room. So let me convert this into feet. So 11 1 by 2 means 23 divided by 2, 11.5 inches. If you want to convert this into feet, that is 0.95 feet plus 35. So width is 35.95 feet. So what is NAFPA 13 standard says, we have to keep this distance between sprinklers is 2 times compared to the distance from the wall to the first sprinkler. So that means we have to keep this distance 2 times, this distance 2 times, this is 2 times, this is 1, and this is 1. So total 2, 4, 6, 7 and 8. So we need to divide this figure by 8. That means each dimension will be 4.5 feet. So since we said that we need to keep this distance twice between the sprinklers, and this distance is half from the wall to the first sprinkler, this distance should be half of the distance between two sprinklers. This is SL rule. So if you see that this is one dimension, you need to multiply with 2. That means 8.99 feet is the distance between this sprinkler to this, then 8.99 between these two, and 8.99 between these two. So I'm gonna write the distance for this section 102 to 101, that is 8.99 feet. 8.99 feet. So 2.74 meter. If I convert this into meter, it will be 2.74 meters. Already applied the for conversion factor in here. So since we don't have any fittings in here, you can see that this is just a straight piece of pipe. So this is 0, and total equivalent length will be the sum of straight and fittings. So we can write equal to sum, or instead of this we can write equal to this plus this. So total equivalent length is 8.99 feet and 2.74 meters. So now we have to calculate the pressure across that sprinkler. But before that, I have to go back in here and let's define the distances as per NAFPA 13 standards. So you can see that this distance is 8.98, this is 8.98, this is 8.98. So we need to multiply with 3, that is 26.96, and we know that total width of the room is 35.95. So we will minus this one. So we are left with 8.98. So we are left with 8.98 means 1 time this distance and 1 time this distance, divide by 2. That means 4.5 feet. 4.5 feet is the distance from the wall to the first sprinkler. So we can write directly the distance between the sprinkler. This is 103 to 102 is 8.9 straight pipe. This is again 8.95. Then 1T to 104, that is 4.5 feet. This is just calculated here, 4.5. So now we are going to calculate the required pressure across that sprinkler having 15.5 GPM. So this is the formula which we are going to use. PT is equal to Q divided by K whole square. So here Q is 15.5 and K is basically our constant factor for the sprinkler. And how you will gonna get this value? This value you have to get from the supplier, the one who supplied you the sprinklers. So you have to check their technical data sheets, their manuals to get this value. So it depends on supplier to supplier. So let's say we got 5.3 sprinkler K value. So I'm gonna use 5.3 in here, and C is basically the pipe roughness. It depends on material to material. So since we have used galvanized steel pipe in here, so its roughness is 120. So there I have a hydraulic calculator. You can see that C value of the different material is given in here. You can see that this is for galvanized steel, this is for mild steel, this is for copper is 140, mild steel is 120, stainless steel is 140. So since we have used galvanized steel, I'm going to select galvanized steel in here, and C factor is 120, you can see. So that's how I select C is 120. So now I'm going to put the values. Q is 15.5 and K is 5.3. So 15.5 divided by 5.3, if we take the square of this one, that is 8.55 or 8.56 psi. So this is psi, 8.56 psi, 8.56 psi. If you want to convert this into bar, you just need to multiply this 8.56 with 0.068, 0.0689. You will get this value in bar, 0.59 bar, 0.59 bar. So now so this is a calculated pressure across sprinkler. So we have to write in here, it's 0.59 bar. Already applied the conversion factor, so we get this value in psi. You can see that 8.56, 8.56. Since there is no change in elevation at this point, PE is basically pressure loss due to change in elevation. There is no change in elevation at this point, so we can write this one 0 bar, that means 0 psi. And PF is basically the pressure loss due to the pipe friction. So this is the hydraulic calculator which I'm gonna use. As you can see that this is the Hazen-Williams equation which I'm gonna use in here to calculate this PF, friction loss or pressure loss. So what is the size in here? Pipe size is 1.049. We have to use actual internal diameter. So 1.49 means in mm it will be 26.64 mm. 26.64 mm. And the flow rate, if you see that total flow rate is 15.5. C factor is already selected, and the length which we used in here, total equivalent length is 2.74 meter. You can see here this one, 2.74 meters, 2.74 0.74 meters. So just calculate and it will give you the total pressure loss is 0.005 bar. Sorry, one thing, this flow rate is in liters per minute and this one we have used in GPM. So this is the liter per minute, 58.7. So 58.7 we have to use in here and then calculate. 2.74 is the, so you can see that total pressure loss is 0.049 bar. 0.049 bar. So we have to write in here 0.049 bar. So this is already calculated into psi. So this is the total pressure, and if we have to calculate the bar per meter pressure loss, so it is very simple. You just need to divide this total pressure in a bar divided by total length. You will get in bar per meter. Same way you need to divide this if you getting in psi per foot. So you need to divide this required pressure divided by the total length in a feet. You will get psi per foot for this one. So now we are moving to the second section, 103 to 102. You can see that 103 to 102 we have this sprinkler in here, and pipe size, if you see that this is 1/4. Pipe size is 1/4 over here. So we have right pipe size 1/4 in here. So 1/4 means if you check the internal diameter of this that is 1.38. If go back to our tables and charts, so 1/4 for schedule 40 pipe normally inside diameter, if you check that, it is 1.38 inches. 1.38 inches. So we have to write 1.38 inches in here, and there is no, again, no fitting in here. It's a straight piece of pipe, so no fitting. So now we have to get the value of the Q first. How we will get this Q value? You have to use this formula. Q is equal to K square root of P. So K, we know that 5.3 is the sprinkler constant, and then square root of P we have to use in here, and P is the total we have to use, that is 9.27. 9.27, and this is basically sum of these three in psi. If you want to get this in bar, same thing you have to do, equal to sum. So you will get 0.64 bar, and total pressure is 9.27 at this point. So we use 9.27 pressure and 5.3 GPM. So let's check. 9.27 square root into 5.3, we'll get 16.14 GPM. 16.14 GPM. The same Q we have to use in here, 16.14. And then how we'll get the capital Q? Capital Q is nothing but sum of these two, the previous one plus the one which we calculated now. So that means flow rate at this point is 31.6 GPM. 31.6 GPM means 119.8 liters per minute. So straight length pipe we already get, this is 8.99 feet. There is no fitting, so it's 0. Total equivalent length equal to straight pipe plus fitting, that is 8.99. So again there is no change in elevation, so we're gonna make it 0. And again we have to apply the Hazen-Williams equation by using this hydraulic calculator. So this time we have 1/4 diameter. So if you want to convert this into inches, that is internal diameter of 1.38 inches into mm, it will be 35.05 mm. So 35.05 mm. Flow rate is how much? Flow rate is 119.8 liters per minute. 119.8 liters per minute. And if you see that total equivalent length is same, 2.74. Calculate. So total pressure loss is 0.049 bar. again 0.049 bar. It will automatically convert to psi, then you can divide per unit length to get into psi per foot or bar per meter. So let's move back, let's move to the third section, that is 104 to 103. If we move back to drawing, that is 104 to 103. So again we have length is 8.99 feet, convert this into meter, and pipe size is again same, that is 1/4. So 104 to 103 we have this sprinkler, this one, and size is 1/4, that is equal to 1.38 inches internal diameter, and again no fittings, so 0. Total equivalent length equal to this one plus straight pipe plus fittings, 8.99. So again we have to calculate the Q first. So how you get this value is, again this is the sum of these three, so we'll do for the bar again, equal to sum these three. So you will get 0.69 bar total pressure in here and 9.98 psi. So Q is equal to K square root of P. To calculate the Q value again, K is 5.3. 5.3 cross square root of P. Total pressure you can see this is 9.98. So 9.98. So check this one is how much, 9.98 square root multiply 5.3, 16.74 GPM. 16.74 GPM. So you can write in here 16.74 GPM. So how you will get total Q again is equal to previous one plus the one which we calculated now. So capital Q is 48.4 GPM. So that means the flow at this point is 48.4 GPM. So now the flow rate is done. Since there is no change in elevation at this point, so we're gonna make it 0. There is no pressure loss due to change in elevation, that's why it's 0. Again we have to use this hydraulic calculator for Hazen-Williams formula, and this time we have again 1.38 inch means 135.05 mm, and flow rate is 183.1. C factor is constant for galvanized steel, and you can see that the length, total equivalent length is 8.99 feet, that means 2.74 meters. So 2.74 meters, calculate. So total pressure loss is 0.110 bar. 0.110 bar. So it will convert into psi by using this conversion factor, and then again you have to divide this factor, this pressure in a bar, divided by total length in a meter to get the bar per meter, and you need to divide this required pressure in psi with total length in a feet to get psi per foot. So let's move further to section 1T to 104. So you can see that this point is 1T and this is 104. So again we have one sprinkler at this point. This is the fourth sprinkler. From 1T to 104 we have this sprinkler, and this distance we already write from this is there we have a T also. You can see that there's a T connection in here, and this distance we already know 4 feet and 5 inches. We already 4.5 feet we already write in here. So since we have one T in here, that's why we write 1T in here. Pipe size is again 1/4. You can see in here pipe size is 1/4. So we write 1/4 in here, that is 1.38 inches internal diameter. And we have one T in here, so we have to write the equivalent length for this T. So move back to our tables chart. This is the equivalent length for C equal to 120, the galvanized steel pipe, schedule 40. So you can see that 1/4 inches in here and T is here. So for T 1/4 inch, this one equivalent length is 6 feet. So we can write in here 6 feet. So it will automatically convert into meters, and then total equivalent length equal to this one plus straight pipe plus fitting, that is 10.5 feet or 3.2 meters. So now what we have to do is we have to calculate the q again. Q is equal to k into square root of p. So k, we know that it's sprinkler constant 5.3 cross square root of p. So total pressure is again at this point is 11.57. So let's calculate this one. 11.57 square root multiply 5.3. So its GPM is 18.03 GPM. 18.03 GPM. So we have to write in here 18.03, and capital Q is again this previous one plus the one which we calculated now. So Q at this point 1T to 104, Q at this point is 66.4 GPM or 251.4 LPM, that is liters per minute. So we know that pipe size is 1.38 inches. So we can now we have to calculate the pressure in here. Just sum up this one to get the total pressure, equal to sum. So we have a change in elevation at this point. This is the cross main and this is the branch line, and we have a change in elevation of 3 feet between the cross main and the branch line. There's a 3 feet change in elevation. So we have to write in here. So we know that if we want to convert this into head, so 1 psi is equal to 2.31 feet. So we can write if there's a 3 feet change in elevation, so 2.31 into 3, so head loss will be 6.93. So we can write there's a pressure loss due to the change in elevation of 3 feet is 6.93 psi. So if you want to convert this into bar, you just need to multiply with 0.0689 equal to this one into 0.0689. So that means 0.48 bar. So now we will calculate the last one, that is PF, using this hydraulic calculator. You can see size is again 1/4, okay, that is 35.05 mm, and flow rate is 251.4, and you can see the length, total equivalent length is 10.5 feet or 3.2 meters. 3.2 meter, and then calculate. Total pressure loss is 0.227 bar. 0.227 bar. 0.227 bar. So, or you can check one thing here directly. This is the pressure loss per meter of the pipe, that is 0.071. 0.071. Or you can just convert it and then calculate it accordingly. So this one is done. So next total pressure will be the sum of these three. As you can see that the first one is 11.57, second is negative 6.93 plus 3.29. So total pressure at this point is 7.93 or 7.94. This is calculated in here, and this one is in the bar. We can just apply the formula to get the total pressure at this point, that is 0.55 bar. And at this point, so now we are at the second point of 3T to 1T. This is 3T and this is 1T. There is no change in elevation, so pressure loss due to the elevation is 0, so we can write 0 in here. And how we'll get the total pressure due to the pipe friction? As you can see that this point pipe diameter is 2 inches. You can see the pipe diameter is 2 inches in here in the drawing, and the distance between the branch lines, this is the branch line, this is the branch line, distance between branch line is 14 feet 11 inches. This is mentioned in here, and 2-inch pipe size, 14 feet 11 inches distance between branch lines. So 14 feet and 11 inches. If you want to convert this into feet, 11 inches means plus 14. That means 14.92 straight feet of pipe. 14.92. And then again we have T at this point again. From there to here we have a T again, this point. So we have to write T in here, this one. And the T for 2-inch diameter. Just check the tables and charts and check the equivalent length for T 2 inches diameter. So T is 2 inches, 2 inches, T, that is 10 feet equivalent length. So we have to write 10 feet in here, and total equivalent length equal to this one plus straight 5 plus fitting equal to 24.92. So last thing remaining in here is we have to calculate the PF, but before that we have to calculate the Q at this point. Since there is no sprinkler at this point, just a straight piece of pipe, as you can see that from 3T to 1T there is no sprinkler, so K factor is 0 at this point, so Q is equal to 0. So we can write small q 0, and capital Q will be same as this one, equal to this one, or we can write like this, equal to this one plus small q is 0. So 66.4 GPM or 251.4. So we have to calculate PF, that is the pressure loss due to the pipe friction, using this hydraulic calculator. At this point we have 2 inches, internal diameter is 2.67, 2.067 into 25.4 to convert this into mm, so 52.5 mm. 52.5 mm, and you can see that GPM is flow rate is in 251.4, it's same, and equivalent length in the meters is 7.60 meters. 7.60 meters, just calculate. So total pressure loss is 0.076 bar, 0.076 bar, that means 1.1 psi. So again you just need to divide this by total length, you will get bar per meter, or you need to divide this psi divided by total feet, that is 24.92, get in psi per feet. So the last one remaining is here. So let's say our source of supply is far away from here, and I'm just writing a length which we don't know in here, so I'm gonna write 150 feet from the source of supply, straight pipe. And let's say we have at this is 5T point and this is 3T point, we are talking about this one. So at this point we have to check the pressure also. So we are going to use this equation, we have to adjust the flow. So we are going to use this equation, Q adjust equal to QL into pH divided by PL, where QL is the flow across low pressure line, pH is the flow across high pressure line, and PL is the pH is the pressure across high pressure line, and PL is the pressure across low pressure line. And why are we doing this one? Because we did not accommodate the flow rate across these sprinklers. There must be some pressure, more pressure at this point due to these sprinklers. So we are adjusting the pressure at this point. So that's why we are using this formula. So Q adjust is equal to QL. QL, as I told you, is the flow across low pressure line. So this is the flow across low pressure line. This is for low pressure line, and this is for high pressure line. So flow across low pressure line 66.4, square root of flow, this is the pressure across high pressure line, and this is the pressure across low pressure line. So high pressure line, you can see the pressure is this one. This is the high pressure, say 9.04. 9.04. And PL is the pressure across low pressure line, is this one. This is the low pressure line, 7.94 psi. 7.94. So we'll just use this formula. 9.04 divided by 7.94, take square root of this one, multiply with 66.4. So you will get 70.85 GPM. 70.85 GPM. So you have to write small q is 70.85, and capital Q is equal to this one plus the one which we calculated now. So total GPM is 137.3 GPM and 519.6 liters per minute. So again, the pipe size is 2 inches in here, so we have used 2-inch pipe size. So we don't know exactly how many elbows and T's up to the point of source of supply. So we just write it roughly that let's say we have 5 elbows and 3 T's from this point to the source of supply. So 3 T's and 5 elbows, and straight pipe length, let's say we got from this point to the source of supply is 150 feet. So we write 150 feet in here. So fittings length we have to write. We see that 2-inch we have 5 elbow and 3 T's. Let's go to table and charts. 2-inch 90-degree standard elbow or long turn elbow. I'm gonna use this 90-degree standard elbow, 2-inch, and its equivalent length is 5. So we have 5 elbows, means 5 into 5, 25 feet is for the elbows. And for T, if you see that 2-inch T is 10. So we have 3T, means 30 is for T's and 25 for elbows, 5 elbows. So total 55 feet. So total equivalent length equal to straight pipe length plus fittings length. Total equivalent length is 205 feet or 62.48 meters. So now we are going to calculate the PT in a bar. It's same as I calculated above, sum of these three values, and then there's no change in elevation, so I'm gonna write 0. And now I'm gonna use again hydraulic calculator or Hazen-Williams formula. So this is 2-inch again, 2.067 means 52.5 mm, and flow rate is how much? 519.6 lpm, 519.6 liters per minute. And length, if you see that total equivalent length is 62.48 meters. 62.48 meters. Calculate. So total pressure loss is 2.374 bar. 2.374 bar. 374 bar. So this one is in psi. Just apply the conversion in here. So again you just need to divide this pressure loss in a bar divided by equivalent length. You will get bar per meter. So for psi is again same thing. You just need to divide psi per foot. You have to divide this required pressure divided by total equivalent length in a feet to get psi per foot. So if you see that the total pressure here is 3 bar. Total pressure here is 3 bar or 43.47 psi, which we calculated in here. And total flow rate, you can see that 137 GPM or 519.6 LPM, or you can say that 520 LPM. So this is how you can perform the sprinkler system hydraulic calculation. I hope you guys learned something from this video. For more videos, keep watching my channel and don't forget to subscribe. Don't forget to press the bell icon. Thank you. Bye bye.